Gabriel Cowan. I'm on the project with Luke Moreland and Robert Shelton. Today I'll be doing part A of the Final Fluids project with the wind tunnel. So let's start off with the geometry by opening it. I'm just gonna walk you through the steps. I'm not gonna actually do it from scratch because that would take forever. So here we have it open. I'll just kind of walk you through the steps. So started in the XY plane. Um, had I made three lines here, here, and here. Made sure it's centered around the midpoint. I then made sure that each line was the length that was specified the uh, in the document. Um, Here you can see. Oh wait, sorry. Yeah. So you have like that, and then afterwards I made vertical lines uh, to then do the height of each thing. So yeah, here you can see the vertical line here, 0.889 meters. Over here, 1.6256 meters for the contraction and diffuser. And this entire length is what was specified, and so is this height, is also the proper height. Pretty easy to CAD, nothing special about it. Okay, so let's go to the mesh. I already have it pulled up because everything takes forever to load. Yeah, so the mesh also not too bad. Basically, I use the triangle method. I just clicked on it and then I made sure to have the body suppressed, no method triangles using goal settings. You just kind of go here, method, and then with the body, apply, and then you would use this triangle method, but I'm not going to do that again because we already did that. Um, yeah, not too bad. And then also I made sure to name the sections velocity inlet, pressure outlet, and the wind tunnel walls. Again, not hard to do. Pretty simple mesh. And then now let's get to the meat and potatoes of this. It's just, the setup and solution. So, you want to make sure that this is viscous. Okay, click the wrong one. This one, yeah, make sure everything is, all of these are selected, standard, enhanced wall treatment, pressure gradient, thermal effects. These are default values. Yeah, make sure it's not laminar and viscid because it's not. Then, yeah, materials, fluid, make sure it's air, air, and you can keep all of these to the default. There's no need to change them. Yeah, and boundary conditions for the inlet. So it's because they want the test section velocity to be 15 meters per second. You have to use the height ratio between the um, contraction cone and the test section to get your inlet velocity so that it becomes 15 meters per second in the cone, and that means that the inlet had to be 5.625 because using mass flow rate and everything like that, it's a ratio. It's just V1 H1 equals V2 H2. Yeah. Wall, make sure it's no slip conditions. Stationary, no slip, pretty easy. And then pressure, same things, same kind of things. Um, Methods, make sure it's coupled. All of these are usually out of the default. Then initialize, yeah, I kept it as 10. And then run your calculations. Yeah, number of iterations. You can do higher if you want um, more accurate data. So, yeah, make sure when your initialization. Sorry. Very simple. And then run your calculations. Okay, now that we're back um, from the solution, as you can see up here, it didn't actually go up to 250 because the solution converged. But yeah, so here is the velocity magnitude contour that it seemed to just do by itself. Yeah, so I guess we'll start with contours. So, yeah, here is the contour for velocity. Nothing crazy. We have to do that for now pressure, pressure, static pressure, boom. High pressure over here, low pressure in the middle, because that's where velocity is maximum, or highest, and maximum, but dynamic pressure, similar stuff. Um, let's see, total pressure. There we go. Here it is, and that's how you do the first part for the contours. Yeah. So that part's done, and then I'll do the stuff along the center line. And we'll do the streamline patterns at the end. So for this one, yeah, for along the center line, uh, sorry about that. Ansys hates me and it crashed. Yeah, so to do it along the center line, we are going to do a new line. Line 4, start at negative. Hold on, sorry about that. Negative 1.956 sorry, to 1.955. And we'll keep it at 0 because we send it around the origin. Oops. So yeah, and to do that, we'll start off with velocity. Yeah, here's the velocity distribution on the center line. We'll do the same with pressure, static pressure, similar to velocity but reversed. Static pressure, dynamic pressure, and total pressure. That is the third point. And so next we have the vertical distribution of velocity, dynamic pressure, and total pressure in the center of the test section. So what we're gonna do is swap these around to 0 and 1, and position on the y-axis. Start with velocity. That is the wrong one. Sorry. Yeah, we're gonna make a new line for the center, starting at 0, 0, going from negative 0.3048 to 3048. Point, yeah. Here, we'll do that, and Here's our, oh, there we go. Yeah, our velocity magnitude. We're gonna do our pressure. Pressure. Yeah, sorry about that. I realized that I also had the vertical line, or the center line selected for those, so they looked a little weird. But that is the second to last thing we have to do, and now we have to do the streamlines. So we will be leaving this section and going to results, and I'll come back after it's loaded. All right, now that it's loaded, here you can see the streamline for beforehand, but let me show you the settings for it. Yeah, so just go up here, click streamlines, surface streamline, symmetry one. This is the amount of points if you want to have. Make sure to click your variables velocity. Yeah. Um, yeah, everything else is just default stuff. Yeah, apply, and then it'll give you this. And that's pretty much it. Yeah, there's nothing else we have to do. So, yeah, thank you for watching. Even though you're probably not. But yeah, thank you.